In this episode, we focus on a specific kind of access constraint that often delivers a big security benefit with a clear intuition behind it: restricting administrative paths to trusted networks. The idea sounds simple, but it becomes tricky in real life because administration is frequently remote. Incidents happen outside normal hours, and teams need to support systems that run everywhere. If you restrict admin access too aggressively, you can slow down troubleshooting and create pressure for exceptions that quietly reopen risk. If you do not restrict it at all, administrative interfaces become durable attack surfaces that attackers can probe constantly. The goal is to find a design where administrative paths are narrow and predictable, so they are harder to attack and easier to monitor, while still being practical for the people who have to keep systems running. Trusted networks do not mean magically safe networks. They mean networks you control well enough to set expectations, enforce device and identity requirements, and observe traffic reliably. As a beginner, you should come away with a mental model for why network restriction matters, what makes a network trusted in practice, and how to support operations without returning to broad exposure. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Start by defining what an administrative path really is, because it is more than a login screen. An administrative path includes the network route, the interface or endpoint being reached, the identity used, and the session through which actions are performed. It might involve a web-based management console, an application programming interface endpoint that changes configuration, or a remote management channel into a system. What makes it sensitive is not the protocol, it is the power behind it, because admin paths can change access controls, reconfigure services, and sometimes even disable security controls. If an attacker can reach the administrative path from anywhere, they can attempt to exploit it from anywhere, and their attempts can be constant and automated. Restricting admin paths to trusted networks reduces reachability, which reduces the number of attackers who can even try, which often reduces both successful compromise and the noise of endless probing. It also creates a more predictable environment for baselining, because admin traffic should come from a small set of known places. This predictability is one of the most practical benefits. When the admin path is narrow, unusual access stands out. Now consider what trusted networks means in a realistic way, because it is not simply the corporate office network versus the internet. A trusted network is one where you can control who can connect, what devices are allowed, and what monitoring and logging exist. It might be a dedicated management network segment inside your cloud environment, where only hardened administrative systems live. It might be a network reached through a secure gateway that enforces authentication and device requirements before allowing access to internal resources. It might be a small set of known external addresses used by a managed administrative environment. The unifying idea is that you can set expectations and enforce them, which is what makes the network trustworthy enough to be part of an access constraint. Beginners sometimes assume trusted means nobody can get in, but in security, trusted is always relative, and it really means controlled and observed. The more control and visibility you have over a network, the safer it is as an origin point for privileged access. Restricting admin paths to trusted networks reduces risk in several concrete ways that matter for cloud environments. First, it blocks opportunistic attacks that rely on scanning public endpoints and trying common exploits, because the interface is not reachable from the public internet. Second, it reduces credential stuffing and brute force attempts because attackers cannot even reach the login prompt unless they are inside the trusted boundary. Third, it makes stolen credentials harder to use remotely, because the attacker would need both the credentials and access to the trusted network, which is an additional hurdle. Fourth, it reduces the chance that a misconfiguration in authentication or authorization becomes immediately exploitable at global scale, because reachability is still constrained. This does not remove the need for strong authentication, but it reduces the number of attempts attackers can make and reduces how quickly a mistake turns into a breach. Beginners can think of it as a layered barrier. Even if one layer weakens, the other still limits exposure. The operational challenge is that administration must still be possible from remote locations, and this is where many designs fail if they do not account for real workflows. If administrators are forced to use a restricted path that is slow, unreliable, or hard to access during an incident, they will look for shortcuts. Those shortcuts might be temporary broad network exposure, sharing credentials, or using unmanaged devices, all of which create durable risk. To keep operations moving, the trusted network approach must provide a reliable entry point for administrators that works from anywhere while still enforcing constraints. The concept here is not to eliminate remote administration, but to centralize it through a controlled doorway. Instead of letting admin interfaces be reachable from everywhere, you let the admin use a controlled gateway to enter a trusted network context, and from there, they can reach administrative endpoints. This is similar to requiring people to enter through a security desk rather than leaving side doors propped open for convenience. The gateway approach preserves the ability to administer remotely while still shrinking exposure. A related operational principle is to make the secure administrative path the default path, not the special path. If the default experience for admins is to work through the trusted network entry point, then it becomes normal and predictable, and people build habits around it. If it is treated as an occasional special process, people will forget how to use it, it will feel inconvenient, and it will be bypassed when stress is high. The default path should also support the common admin tasks, not just a narrow subset, because partial solutions create pressure for exceptions. The more complete the trusted network admin path is, the fewer reasons teams have to open up public admin exposure. Beginners should remember that durable security often comes from good defaults and repeatable habits. If your secure path is smooth and reliable, you reduce the temptation to create insecure workarounds. Another key idea is to segment administrative reachability inside the trusted network, because trusted does not mean everything should be reachable by every admin from everywhere. A well-designed trusted network approach still uses least privilege and tight scoping so that only the necessary admin systems can reach the necessary admin endpoints. For example, administrative access to storage management might come from a specific management subnet, while administrative access to application deployment might come from a different controlled environment. This internal scoping reduces blast radius if something inside the trusted network is compromised. It also supports monitoring because you can baseline which admin systems should reach which services. If one admin workstation suddenly reaches a service it never touches, that is an anomaly worth investigating. Beginners can see that this is the same boundary thinking applied to networks rather than data. The trusted network is a boundary, but inside that boundary, you still want smaller boundaries that reflect purpose and sensitivity. Logging and monitoring become more practical when admin paths are restricted because the signal-to-noise ratio improves. Publicly reachable admin interfaces can attract constant scanning and failed login attempts, which can overwhelm logs and make it harder to spot meaningful events. When you restrict reachability, the remaining access attempts are more likely to be legitimate or at least more likely to be significant. That means you can treat events with higher sensitivity, such as unexpected login attempts, unusual action sequences, or administrative actions performed outside expected windows. You also gain a clearer ability to correlate identity behavior with network origin, because admin sessions should originate from a narrow set of trusted network points. If an admin identity is used from outside that set, it becomes an immediate high-confidence signal of compromise or misrouting. Beginners should notice how this connects to earlier episodes on access patterns and anomalies. Restricting the admin path makes patterns clearer, which makes anomalies stronger signals. There is also a relationship between trusted networks and change control, because changes to network restrictions are themselves high-risk events. If someone broadens the allowed network scope for admin access, that could reintroduce a durable attack surface. This means network scope changes should be treated like permission changes, with strong visibility, review, and ownership. A secure program watches for scope widening, because widening is often the first step in accidental exposure or intentional compromise. It is also important to plan for legitimate temporary widening, such as during migrations or emergency vendor support. But those cases should be time-limited and documented. Beginners should understand that the weakest point in a restricted network design is often the exception process. If exceptions are frequent, uncontrolled, or permanent, the benefits of restriction erode. A durable approach makes exceptions rare, traceable, and designed to expire. Finally, you need an emergency mindset that keeps the trusted network model intact during incidents, because incidents are when teams are most likely to break their own rules. If an outage happens and an admin cannot reach a system through the trusted path, the temptation is to open public access quickly. That quick fix can become the new normal if it is not reversed, and it can also expose the system to immediate attack during a vulnerable moment. Keeping operations moving means the trusted path must be resilient, and it means the organization should have a defined emergency access plan that still uses control and logging rather than broad exposure. The principle is to pre-plan the hard moments so you do not improvise risky shortcuts. For beginners, this reinforces the idea that security architecture must account for stress and urgency, because that is when attackers often take advantage. When you put it all together, restricting administrative paths to trusted networks is a powerful way to shrink attack surface while improving detection and control, but it only works if it supports the real needs of operations. You begin by recognizing that admin paths are uniquely sensitive because they enable high-impact changes and can expand compromise rapidly. You choose trusted networks that are controlled and observed, and you funnel administrative access through a reliable, centralized entry point that works for remote administrators without exposing management interfaces publicly. You keep the secure path as the default, reduce exceptions, and segment reachability even within the trusted boundary to limit blast radius. You pair network restriction with strong identity controls and disciplined logging so that the remaining admin activity is high signal and easier to monitor. Finally, you design for emergencies so the trusted model holds under pressure rather than being abandoned. The result is an administrative access posture that is narrow, predictable, and defensible, while still allowing teams to keep systems running when it matters most.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.